Hello, I want to talk to you today about SN1 and E1 reactions. We've been talking about substitution reactions in class, and I want to make sure we're comfortable with some details of SN1 and E1 reactions, and then we're going to do some examples. So what I have on the board are just some notes about SN1 and E1 reactions, just a summary of the things that are in the book and the things I want you to think about when you're doing substitution and elimination problems. So for SN1 reactions, the key intermediate, as we've talked about, is the carbocation, right? And we need to think about that when we're doing SN1 and E1 reactions. We form the carbocation. We're always aware of rearrangement, right? And as we know about carbocation stability, it's going to be favored when it's a tertiary alkyl halide. It's possible with a secondary alkyl halide, and it's not going to happen with a primary alkyl halide because the carbocation is not going to be stable enough to form. It also will not happen if there's a strong nucleophile or base present. In that case, it's going to promote SN2 and E2, and I'll make a separate video on SN2 and E2 reactions. It's only possible when there's an alcohol solvent, right? So SN1, E1, we're going to have a tertiary or secondary substrate. We're not going to have a nucleophile or base present, and we're going to have an alcohol solvent. Again, as we talked about in class, and as it talks about in the book, the alcohol solvent is going to stabilize the transition state. It's going to essentially help pull apart that alkyl halide to form the high energy carbocation intermediate. Normally we're going to have to heat this reaction, though you won't always see heat when you look at the reaction conditions. I might forget it, they might forget it in the book. If we're starting with one enantiomer, we're going to get a racemic mixture of SN1 products. Again, carbocation destroys the stereochemistry. It's an achiral intermediate. We can add the nucleophile from the top or the bottom face. E1 is going to yield all possible alkene products. You form the carbocation, you look to find the beta protons. Elimination of those will give you the alkene products. For alkyl halides, and again, this is key just for alkyl halides, it's going to be a little bit different when we get to alcohols, and we'll talk about that in the future. SN1 and E1 are going to occur together. Whenever you get SN1, you're going to get E1. Right? SN1 will be the major product, E1 will be the minor product or products. Right? E1 products are formed in proportion to alkene stability. So you're going to look at the alkene products you get from E1. The ones that are more highly substituted are going to form more. The ones that are less highly substituted you will form less of. So you have major E1 products and minor E1 products. All right, so let's do some examples and apply some of these rules to 3 different examples. So our first example, we're going to look at T-butyl bromide. All right, and we're going to react T-butyl bromide with ethanol and heat. All right, this is probably the simplest SN1 reaction that we'll see. Right, and again, when we think about it, let's go through the mechanism. So first, we're going to break the carbon-bromine bond. That's going to yield a tertiary carbocation. Ethanol can then attack that carbocation. Right, that's going to give us another cation where we have a positive charge on oxygen. Right, and then that's going to enable us to get to our final product. So sometimes people will write that the bromide is going to pull off the H. Probably better to write that ethanol is going to pull off that H, and that's going to give us our product, which is an ether. All right, so that's how we're going to get to our SN1 product. And again, we said we're going to get E1 and SN1 products. SN1 is going to be the major product, right? So that's going to be our major product, right? When we think about how we get to the E1 products, let's just redraw the carbocation over here to focus on E1. And in this case, we're going to pull off a beta proton. Again, label the carbon where the carbocation is alpha. That's where the halogen started. We're going to pull off a beta proton because this is a beta elimination. And again, we'll probably just use ethanol as the base. Can pull off that proton, CH bond electrons, will go towards the cation, and that will yield our alkene product. And again, this is going to be our E1 product, and that's going to be the minor product. All right, so that's a relatively simple SN1 E1 problem. All right, let's look at another reaction where we start with 1 enantiomer and we see what happens in this case. All right, so let's keep those separate. So we're going to start with that chiral iodide. All right, let's start with 1 enantiomer of that chiral iodide. And in this case, we're going to react it, let's do it in T-butanol and heat, right? And we're going to get a variety of products here. So let's draw out the products this time, and then we'll figure out mechanisms to get there. So this is 1 enantiomer. We said we're going to get 2 enantiomers of the product. So we're going to get a racemic mixture of our SN1 products, and these will be our major products, right? So those are our SN1 products. We're also going to get 3 elimination products, right? These are going to be our E1 products, right? And we're going to get more of the more stable trans disubstituted alkene all the way over here. We're going to get less of that monosubstituted terminal alkene. So in this reaction, we're going to get 5 products, right? So let's look at the mechanism. Again, it's going to look very similar to what we have above. We're going to form a secondary carbocation. T-butanol can then add to the carbocation. And again, it can add from the top or the bottom, right? So we're going to have that bond coming out and that bond going back, right? And now we can just do a simple proton transfer like we did above. I'll just abbreviate that by saying PT, right? Proton transfer to the solvent to get us to our SN1 product. So the same mechanism we did above, right? To get to these products over here for the E1, again, let's redraw the carbocation, right? That's the alpha carbon, and then we have 2 beta carbons. And we have 3 different types of protons. So when we eliminate these different types of protons, if we eliminate the beta carbon from the beta carbon over here, right? So if we have our T-butanol, right, to grab either that one or that one, we're going to form the disubstituted alkenes, right? And then if we have T-butanol attack the other beta position, we're going to form the monosubstituted alkene, right? So in this case, we get 5 products from this relatively simple reaction, right? Let's do one more example. A little bit more complicated substrate this time. Not too much, though. All right, let's do methanol and heat. And for this one, let's do it the way that we should do this when we approach a problem on a problem set or an exam. All right, let's identify that we have a secondary alkyl halide. All right, we have no strong nucleophile or base, and we have an alcohol solvent. That tells us this must be SN1 E1. Okay, so let's go ahead and do the mechanism for that. Again, let's resist drawing out the products. So we're going to ionize. We form a secondary carbocation. Like we always should do when we do these problems, let's ask, can we rearrange? So is rearrangement possible? So will we form a more stable carbocation if we rearrange? And if we look over here, we have a T-butyl substituent next to a secondary carbocation. That tells us that we can rearrange. We can do a methyl shift. And if we do that methyl shift, we're going to end up with, and again, let's remind ourselves we have a hydrogen on that carbocation. If we do that methyl shift, we're going to end up with a tertiary carbocation, right? So we've made a more stable carbocation, right? Clearly this is something that's going to be favored. So again, don't forget that rearrangements can occur. And so now we can add methanol for our SN1 reaction. And again, we'll do the proton transfer. I won't draw that out, just like we did on the first one though. You can see what that would look like. So what are we going to get for this product? Right, we're going to make that ether. And again, if we had just drawn the product out without going through the mechanism, we might have missed the rearrangement and would have gotten the wrong product, right? So very important to draw out the steps in the mechanism to catch the rearrangement. So that's SN1. That's going to be our major product, right? Let's look at what we're going to get for our E1 products. So again, let's redraw the carbocation. There's our carbocation, alpha position, beta, and beta. So we have two different types of protons, so we're going to get two different E1 products. So we're going to have methanol can attack at that position, right? Or methanol can attack there, right? One or the other. So that will give us these two E2 products, right? And we notice that this one is tetrasubstituted, that one is disubstituted. So E1 is going to be the minor, as we said, but this will be there'll be more of that one, there will be less of that one because of the alkene stability. So hopefully this has been a good overview of SN1 and E1 chemistry. And again, we'll have plenty of opportunities to practice this on problem sets in the future.